Hello, we just finished up part 2 of our series on global warming, so we're going to start part 3 today. And what we're going to take a look at today is we're going to take a look at the greenhouse gas. So we talked about what the greenhouse effect was. So let's take a look at the gases and what types of gases create this greenhouse effect. Now in our atmosphere we have carbon dioxide. And right now roughly 54% of the greenhouse gases are considered to be carbon dioxide. Methane is 12%. CFCs, or chlorofluorocarbons, if you sound it out, it's not too hard to spell out, but it is a long word, equal 21%. Nitrous oxide equals 6%, and ozone equals 7%. Now you might be looking at these percentages and thinking to yourself, I thought my science teacher told me that a lot of the atmosphere was nitrogen. And your science teacher was right. Now, what are the greenhouse gases? So when we look at carbon dioxide being 54% of the greenhouse gases, that's just it. Out of all the greenhouse gases, it makes up 54% of the greenhouse gases, not out of the total atmosphere. So let's take a look. We'll look at it in a graph form. Here again, you can see 54%. So a majority of the greenhouse gases are carbon dioxide. But if we look at our total atmosphere, here again, nitrogen is the #1 gas in the atmosphere. Then you have oxygen, which is good because we need it to breathe. And out of all that, the other is 1.4%. And let's look at that other 1.4%. We have argon, we have water vapor, carbon dioxide. And if you look closely, carbon dioxide is only 0.035% of that 1.4%. So a very, 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 very small part of the atmosphere is actually carbon dioxide. When you look at methane, it's 0.00015%. Nitrous oxide is 0.00003%. Ozone is 0.00005%. And CFCs, chlorofluorocarbons, 0.0000001%. Now, what does this tell you? Well, it should tell you that, even though a majority of the atmosphere is not greenhouse gases, a small change in the greenhouse gases can have a big impact on the global radiation budget. So, let's look at it this way. Our planet is really happy when everything's in check. When we have just the right amount of greenhouse gases, things are really, really good. But if we get too much of it, abnormal levels, abnormal high levels, possibly influenced by man's action, whether it's the burning of fossil fuels to use in our cars, maybe it's the burning of fossil fuels to use to create electricity. It could be methane from other sources. We'll talk about a few of those sources today. But if things are out of balance, our planet really is not a happy camper. Water vapor is actually the most important greenhouse gas. And I know some of you are saying, wait, Mr. Attune, you just told us that CO2 is, carbon dioxide is. What's going on? Well, here, look at it this way. Humans have very little control over water vapor. We can't control the amount of it. However, we can control the amount of carbon dioxide. Now, CO2 is the greenhouse gas humans are influencing the most. So, put it this way. If I ask you a question, what's the #1 greenhouse gas in the atmosphere that we have no control over? You can say water vapor. But if I ask you the question, what is the #1 greenhouse gas in the atmosphere we do have control over? It's carbon dioxide. Now here's a neat statistics. Each year, 20 tons of carbon in the form of carbon dioxide, roughly the mass of 4 adult elephants, are added to the atmosphere for each person in the United States. Which means last year you added enough carbon in the atmosphere, 20 tons of it, and that would roughly equal the mass of 4 adult elephants. Now I might say, well, what do I do? Well, some of it you're breathing out is a tribute to you that comes out of a coal-burning power plant. Your parents drive you around in their cars. All that's contributed to you. And we don't always understand this because when we breathe out, we don't think that that gas has mass, but it does. If you remember back in the beginning of the year, we proved that air is mass. We took a balloon, we measured its mass before we blew into it, and then we blew into it, and there was actually a greater mass. So if we add all the carbon dioxide into a large balloon, that balloon would equal 20 tons. Now CO2 was naturally in the air, but humans have dramatically increased the level of CO2 since the Industrial Revolution. Now we continue to emit carbon dioxide into the air with cars, manufacturing, the burning of rainforests, and the cutting down of trees. Here's a graph. You can see since about 57 or so, you can see that we had about 320, about 315 parts per billion. Now look up here. Look how much higher we are in year 2000, 2002, 2003. We've dramatically increased the amount of carbon dioxide in the atmosphere. Here are some common sources of carbon dioxide: power plants, burning forests, cars, trucks, buses. Now, the destruction of trees actually creates a shortage of plants to remove carbon dioxide from the air. We also release carbon dioxide into the atmosphere when we burn fossil fuels for the generation of electricity. In the last 200 years alone, levels have risen almost 30%. Methane. Methane is another natural greenhouse gas, and it's created naturally from decomposing matter in swamps. Methane is, remember, CH4. CH4 is used in industries as a starting material for many different chemicals. Methane also comes from cow gas, coal mining, natural gas fumes, landfills, as well as wood burning. In the last 200 years, methane levels have increased by about 145%. Some common sources of methane are, obviously, fossil fuel production, wetlands. Rice cultivation, believe it or not, actually creates a lot of methane. Termites, cattle, goats, camels, all are sources of methane. So here, let's take a look. This is an interesting chart. How methane has increased with population growth. So as human population has grown, methane levels have also gone up. Now some people might look at it and say, well, why? What do we have done as humans? It's not like we pass gas that much. Well, it's everything else that goes along with it. If you look over on the left, you see world livestock population. As the population of humans have grown, more rice cultivation to feed the growing population of the planet. We also burn more coal to give all of us humans the electricity that we want and we need. CFCs is another greenhouse gas. Remember, it's called chlorofluorocarbons, but we'll call it CFCs. Now, these were never naturally in the air. This gas was used mostly in aerosol spray cans, like your spray paint and hairsprays. It was used as a refrigerant for air conditioners, cleaning solvents, packing materials. Using CFCs and aerosol sprays have actually been banned in the United States and most other parts of the world. So, again, we're here is CFCs were never naturally in the air. Any CFCs in the atmosphere are 100% due to us as humans. Some sources of CFCs: aerosols, insulation material, refrigerants. Now, you're not going to find CFCs in all these materials. Since we figured out that they are bad, they've actually been banned here in the United States, and they're not used nearly as much. Nitrous oxide, N2O, is emitted during agricultural and industrial activities and during the burning of solid waste and fossil fuels. How many of you have heard of nitrous oxide? Sometimes you see it in the movies. If you're racing a car, they'll add nitrous oxide to the fuel to get a little bit more oomph out of their car, a little bit more power. You've also probably seen nitrous oxide if you've gone to the dentist. It's another name for it is called laughing gas. Now, in the last 200 years, nitrous oxide levels have increased by about 15%. Some common sources of nitrous oxide. You're going to find it naturally in the soils. Burning fossil fuels. Golly, we've seen burning fossil fuels on almost every one of these slides that talks about the different greenhouse gases. You're also going to find it in chemical fertilizers. Now, each greenhouse gas, that carbon dioxide, is a sheet. Now, is a sheet going to keep you very warm at night on a cold night? No. Now, what does a sheet do? Does a sheet warm you up? No. A sheet just traps the body heat that you produce close to you. Now, in the wintertime when it's really cold, it's not going to trap a lot of heat. So what do you usually do? Usually get a little bit thicker blanket. So if we get a blanket, that might be methane. Now, the methane is going to trap more heat than, say, a carbon dioxide. But is it always going to trap as much heat as you need? Well, if it's a really cold night, you might want a really thick quilt. And that thick quilt might represent nitrous oxide, which absorbs 310 times more heat per molecule than